Hello everybody. Uh, this video is going to be dealing with a question of when do solar panels become economical? Let me start by saying here's one way to think about it. Say for example that you somehow or another had $2,000 and you wanted to either invest it in some investment or you wanted to buy a solar panel. Now, you will see why I chose the number $2,000. So today, a pretty or actually aggressive investment of $2,000, if you were very, very lucky and prudent, it might return 5% on your money. Remember, CDs now are less than 1%. Municipal bonds are about 3%. The stock market, if you're lucky and can tolerate the risk, might do better than 5%. But anyway, I've just picked 5%. So let's assume that you found an investment you're comfortable in that returned you 5%. 5% on $2,000 would yield $8.33 per month of cash. Which would be taxable, by the way. So now, let's take that $2,000 and see what we could do with that. Now, what I'd like to do is to work in increments of 1 kilowatt, just because it's a round number. So now, if you were to somehow or another find a 1 kilowatt solar panel, how much electricity would it make? And if you were to sell that back to the utility company, how much would they pay you? So let's go through those calculations. And now with the web, it gets very easy. So let's Google PV watts. And the first site comes up is a government site. And we're going to scroll down here on this mighty fine map and click Louisiana. And we're going to click Lake Charles because that's where the data is taken. Now, all we got to do is fill in the blanks, and this thing will tell us how much electricity this thing will make. So we have arbitrarily chosen a 1 kW panel. We'll put 1 kW in here. It also turns out that that solar panels produce direct current, and to sell energy back to utility, we got to convert it into AC. And that conversion factor is 0.9. All right. Now the next thing we got to do is we got to figure out at what angle these panels are going to be on the horizon. Well, it turns out because we're on the 30th latitude, the most optimum angle is 30 degrees. But you can put in whatever angle your roof makes. It also makes a difference at which azimuth you point these solar panels, and it turns out that in our area 180 degrees is the optimum. Now because we're in Lafayette Parish and on the LUS system, the cost per kilowatt is about 9 cents. So if we were to produce kilowatts, we could sell it back to the city, actually trade it back to the city for 9 cents per kilowatt hour. We push the calculate button, and up comes a very interesting table. It says that in January, we would produce 102 kilowatt hours, which is almost the lowest month. Actually, the lowest month is in December, which is 99 kilowatts. Now this is a 30-year average. The government has gone back and averaged the weather over the last 30 years, and this would be a typical year based on 30 years of data. So in January we produce 102 kilowatts. In July we would, or August, we would produce 137 kilowatts. So all year we would take and produce 1,507 kilowatts. Now I'm going to go back to the spreadsheet where I'm going to plug this number in, and I want to get to a monthly average. So if I divide the total production 1507 by 12, it turns out that on an average I'm going to produce 126 kilowatt hours, and if I sold that back to the LUS system, I would they would send me a check for $11.30. So on increments of kW, we would be making and assuming that we could only get 5% on our investment. It looks like the solar panel is a pretty good investment. Now, let's see how I got to that $2,000. Well, a solar panel system consists of two basic components. One is the panel itself, and the other is the device that converts direct current into alternating current. Well, if you're very frugal and you do some searching on the internet, you can buy solar panels for about $1.25 a watt. And if you look around, you can also buy an inverter at about 60 cents per watt. Now, you can't do this on a 1 kilowatt panel. You have to scale it up to 4 or 5 kilowatt increments. But if you're frugal and you can install these things for yourselves, your direct cost is $1.85, and you got to get it shipped here. So let's just assume that we could buy panels at $2 per watt. So that 1 kW panel that we ran the calculations on would cost us $2,000. So in summary, if you had $2,000 investment to make and you were trying to decide whether you wanted to put it in the stock market or put it in the solar panels, these economics indicate that the solar panel would be a better investment. Now, kind of the help is the state has offsets, so the state will give you half of your investment. So now your cost down is $1 per watt, and if the Fed comes back, you get 30%. So in summary, I believe that solar panels in today's economics make sense.